Hi you guys, I'm sorry that I had to leave today, but I'm not feeling the best. So what I decided to do was to record 2 examples of what I expect for you to do on your own today while I'm gone. This is from section 4.6. It's kind of a combination of 4.6 and 4.5. Last class period we used the remainder theorem and we used trial and error in order to find all the answers to a given polynomial. Today we're going to do the exact same thing, but we're going to get a little extra help because it's not always the easiest method to use. So what I have 2 examples for you. The first example is f of x equals 2x squared plus 7x minus 4, and I've gone ahead and graphed it on Desmos for you. That's kind of our added in step today. Let's start off with information that we know prior to this class period. The leading coefficient in this case is at 2. The degree is at 2. The number of terms is a 3. So since I have 2 degree and a 3-term problem, I have a quadratic trinomial. My end behavior, without even having to look at the graph, since my degree is even and the leading coefficient is positive, the ends of my graph should be going to positive infinity on both the left and right. Possible zeros, that's our rational root theorem. We use P over Q for that. Our P value in this case is 4. Our Q value is 2. So our possible answers are factors of 4, which are 1, 2, and 4, over factors of 2, which are 1 and 2. So my actual possible answers for this problem are 1 over 1, which is 1, 2 over 1, which is 2, 4 over 1, which is 4, and now we do them over 2 as well. 1 over 2 is a half. 2 over 2 is 1, and 4 over 2 is 2. Now that being said, these are my possibilities. I have 8 possible answers. The fundamental theorem of algebra says that my answer should be 2. So of these 8 answers, 2 of them will hopefully work unless we have imaginary solutions. And this is where the graph comes in handy. Now what we've been doing with the rational root theorem is we've been basically using the remainder idea, that we want the remainder to be 0 when we use synthetic division. Now when the remainder is 0, that means I'm putting in an x value and the answer to the problem is 0. In those cases we call those the x-intercepts. If you look at my graph, it's very easy to tell what my x-intercepts are. It looks like they're at -4 and +1. I just used the online Desmos calculator to help me graph it. So my possible answers are probably closer to -4 and 1. But in order to do this, to get the hang of it, we are actually going to go through the process of proving that. So this is what I expect to see on your paper when you're doing your math problems for today. You're going to have 4 of them. Well, since it looked like it went through -4, I'm going to divide by -4. So I do the problem just like we would any other polynomial. I drop down my first term. I take -4 times 2, which is -8. I drop down my term, I get -1. -4 times -1 is +4, yielding a remainder of 0, which is what we wanted. Now I have left, it does equal 0. I have -1 and x. Well, that's 2x minus 1. So to solve that problem, I'm going to add 1. So we get 2x equals 1. Divide by 2, I get x equals 1/2. So the answer was close to 1. It was actually a half. The other answer was what we divided by, which gave us a remainder of 0, which is -4. Now, a lot of times you'll be able to read these for this assignment using that graph, but I do expect you to go ahead and prove it for me, which means I do expect you to go ahead and do the synthetic division and then take what you have left over and solve. Notice my answers do exist in my possible answers that I had. I did have positive 1/2, and I did have -4 as possibilities. Let's try another one. Instead of a degree of 2, this one we're going to do is a degree of 3. In this case, the leading coefficient is -12 when we put them in standard form. The number of terms in this problem are 4. So we classify something that has degree 3 as a cubic. Something that has 4 terms we call a polynomial. Now I could look at my graph and try to figure out what the ends are, or I could think about it. We have our graphic organizer for the end behavior of a graph. My leading degree is odd. Okay, my leading coefficient is negative. And we know that odd and negative on range goes to positive infinity on the left and negative infinity on the right. Now we're going to list our possible zeros. My p-value in this case is 6. My q-value is 12. Don't worry about the sign. Factors of 6 are 1, 2, 3, and 6. Factors of 12 are a little bit more. We have 1, 2, 3, 4, 6, and 12. So remember, it's all the factors of the last over all the factors of the first. So we know possible zeros, I'm going to kind of just write it down below here, are all over 1, so it's just those first values we have listed. So 1, 2, 3, and 6. That takes care of 1. So now I'm going to put them all over 2. So 1 over 2 is a half. 2 over 2 is 1. We already have that listed as a possibility, so we're okay there. 3 over 2 is not listed, so we'll put that down as well. So plus 3 over 2, plus or minus 3 over 2. 6 over 2 is 3. We also have that listed as well. Now let's do 3. 1 over 3 is a third. We don't have that listed. 2 over 3 is 2/3. We don't have that listed. 3 over 3 is 1. 6 over 3 is 2. We already have those listed, so we do not have to write them again. Now we'll try 4. 1 over 4 is 1/4. 2 over 4 is a half. We already have that. 3 over 4 is 3/4. We don't have that one. And 6 over 4 is 3/2. We already have that one as well. Now we'll do 6. I'm kind of running out of room, so I'll just kind of put it here above. 1 over 6 is 1/6. We don't have that one. 2 over 6 is a third. We have that one. 3 over 6 is a half. We have that one. And 6 over 6 is 1. We have that one as well. Now we have to do 12, and then we are done. So 1 over 12 is a 12th. 2 over 12 is a 6th. We already have. 3 over 12 is a 4th. We already have. And 6 over 12 is a half. We already have. So I've created a ton of possible zeros. Now that doesn't mean they're all going to be answers to the problem. It's just those are kind of our possibilities. So what I'm going to do is I'm going to look at my graph. And my graph looks like it intersects exactly at 3. I'm using Desmos. So possibilities I'm going to try are 3. Now if you zoom in on your Desmos, and I can't do that because I have a snapshot, this ends up being -1/4. So I'm going to go ahead, it says -0.25. I'm going to go ahead and try that one as well. Now, just like when doing the rational root theorem and just doing trial and error for a third degree problem, you got a little more work to do with these. So that is why I'm going to list both. So hopefully those will both help us. So we start just like before. We do our synthetic division. So negative 12, 25, 31, and 6. We're going to divide by 3. So the first one comes down, so we have negative 12. 3 times negative 12 is negative 36. Add down, we get negative 11. 3 times negative 11 is negative 33. Add down, we get negative 2. 3 times negative 2 is negative 6. Add down, we get 0. Well, then that leaves me with basically negative 12x squared minus 11x minus 2 equals 0. But that's not the easiest problem to do. So this is kind of like one of those where we might want to try just dividing by something else we know that works. In this case is negative 1/4. So I'm going to take it and I'm going to divide it once again by negative 1/4. Now taking a fourth of a number is basically dividing it by 4. So this shouldn't be too bad. So my first digit comes down, no different. A negative times a negative is a positive. And 12 divided by 4 is 3. I add down and get negative 8. A negative times a negative is a positive. 8 divided by 4 is 2. Add down and get 0, which is my goal. So now my math problem is pretty easy. It's actually just negative 12x minus 8 equals 0. Now, I could have factored it up above or used the quadratic formula to solve for the other two answers. But why do that if I already know one of the answers? It's just kind of silly. So we add 8. We get negative 12x equals 8. And we divide by negative 12. Well, negative 8 and negative 12 are both divisible by 4. So my answers to my math problem are x equals 3, x equals negative 1/4, and x equals negative 2/3. 3 answers which all exist in those possibilities that we had down below. Now, otherwise, without the graph, it made it taken a lot of work. Okay, hopefully this is helpful. You're going to try 2 of each, 2 quadratics and 2 cubics. I know it's kind of tedious. I do expect you to show the synthetic division, even though you may be able to read the answers using the graph. But I do expect you to show the steps in order to get credit. After you've viewed this video, you can get your worksheet out and try those 4 problems. Additionally, if you didn't get today's assignment done, you need to work on that. And then you also have your problem of the week that is due to me on Tuesday. So please make sure that you get all your work done. There shouldn't be any slacking. There shouldn't be any going to any other room. You should be staying in here doing your math. No excuses. I will be here tomorrow unless I'm on my deathbed. Questions? If you have questions, you can ask Miss Kennedy for help.